Yesterday we kind of covered quite a few things about our engine fundamentals, right? We talked about the 4 strokes in the engine. We started talking about engine block components, kind of what makes that stuff up today, that you have on your notes. Today, because we're going to get into some other notes, do not add these notes to yesterday's notes. Okay, keep these separate. What I'd like you to do is open up to a blank sheet of paper, right? Write engine fundamentals again, write your name, and write today's date, the September 17th. Okay, the reason why we're doing that is so that way we can kind of compartmentalize, hey, this is what we talked about yesterday, this is what we're talking about today. Again, if people are not here on today's date, then it's easier to kind of say, okay, this is where we started. All right, this is the information we got through. Hopefully we can get through most of this today. I think there's still going to be a little bit left over tomorrow, but that's planned. And then we'll go from there, okay? Now, on my notes, it said that we were starting off on number 17. So let me just back up 1 second to slide 16, if my computer's going to want me to. I don't know why my clicker's been not working very well today. So we talked about the front and rear main oil seal, right? The crankshaft is sticking out the engine block in the front. It's called the snout. And we have part of the crankshaft sticking out the back of the engine. That's the flange. We have to have a seal to still allow that crankshaft to spin while preventing oil from leaking out. These are not fun to replace. They do go bad, so if you have an oil leak, you notice it's coming from the front part of the engine or the rear part of the engine where the transmission meets up, could be possible that this is bad, okay? So there you go. You already know enough information about this to potentially make a diagnosis about an oil leak. That's pretty powerful, okay? All right, I'm gonna just touch the board here. All right, because that crankshaft is sitting out the front and the back, on the back portion of that, the flange part of the crankshaft, we can actually bolt up either a flywheel or a flex plate, okay? What's the difference between a flywheel and a flex plate? I'm not going to get into a ton of details. All you need to realize is that a flywheel is the term we use when a manual transmission is hooked up to the engine. A flex plate is essentially the same thing, but an automatic transmission is hooked up to the engine, okay? More often than not, in 2024, you're going to have a flex plate because most vehicles are automatic transmissions. Okay. Now, on these flex plates or flywheels, this is where we're going to get our gears, or our ring gear. Okay, I'm going to try to draw this on the outside. You can kind of see that a little bit. And this is where our starting motor engages and starts our engine. Okay, so whenever you turn the key to start your car, you push the button depending on what kind of ignition system you have. A starter motor is going to engage this gear and it's going to physically turn or spin the crankshaft. Okay. As it's physically turning the crankshaft, it's causing the pistons to move up and down in the engine block. And all we're trying to do is get one of those pistons to go through a compression cycle or compression stroke. We can ignite the air-fuel mixture with the spark plug. Boom, now we have power. Now all of a sudden, we have the engine being able to supply the energy to run. Now we don't need to have the starter motor to continuously turn that, okay? So that's kind of how that would go. You can see here, here's the back of my engine. Here's that flywheel that's on there. It's actually bolted into the crankshaft itself. Okay, actually I think that's going to be more of a flex plate. Again, we're not going to get into the details of this right now. You just need to know that on the crankshaft flange is our flywheel or flex plate. Now, the piston is connected to the crankshaft using a connecting rod. I know, right? Who would have thought? Why would we call it a connecting rod? All right, connecting rod. Think of it like this. Okay, right here we got a hole. The piston is going to attach to that. All right, and then we got this larger hole that basically is gripping onto the crankshaft. So our crankshaft is going through here. as that piston is moving up and down in the cylinder that's connected to the crankshaft through the connecting rod. Again, if I go back to the idea of you riding a bike, right? Your feet are pedaling and your knees are going up and down. Your femur, the bone in your leg, is connecting your knee to your ankles. In this case, the connecting rod is your femur. Connects the piston to the crankshaft. Okay?
Fingers up here.
Is the femur here?
I think so.
What's down here? Tibula? I don't know. I don't know human anatomy. I just know cars. That's why I can no longer practice medicine. Mr. Geske, you were a doctor. Yeah, I was. Until that one surgery I did. I'm joking, by the way. I'm not a doctor. All right, the piston. The piston's going to have 3 rings. The joke I always make is 3 rings to rule them all, and in the darkness spite them. Any Lord of the Rings fans? No? Okay. It's okay. Piston. Here's my cylinder wall, right here. Okay? My piston's right here. Okay? I've got 1, 2, 3 rings. The top 2 rings, right there, are going to essentially seal the piston against the cylinder wall. Okay? The piston by itself never actually comes in contact with the cylinder wall. At least it shouldn't. All right? Which means, unfortunately, if I'm trying to compress that air-fuel mixture in the combustion chamber, what is preventing that air-fuel mixture from actually escaping or being pushed in between the piston and the cylinder wall? Okay? Well, the answer to that question is the top 2 piston rings. Okay? They're going to prevent what's called blow-by, which is the gases escaping between the piston and the cylinder. Okay? So the piston, or top 2 piston rings seals the piston against the cylinder. So this thing's moving up and down. It's scraping the inside of the cylinder. Okay? Now, to make sure that that's not wearing out or heating up too much, we have oil that's going to be basically thrown up on the cylinder walls as lubrication for that. Okay, unfortunately, we don't want the oil to be able to go past these rings and get into the combustion chamber. That would be bad because oil burns. Right? We only want to be burning gasoline and air. So the 3rd ring is what's considered an oil control ring. Okay? This oil control ring right here, this is if you were to slice this in half, is literally scraping the cylinder wall, and any oil that was splashed up here is actually going to be controlled, and this is preventing oil from getting up into the combustion chamber. Okay, so here's the top of the piston. Okay, so the 3rd ring is oil control ring. Oil control. These 2 piston rings are sealing and preventing blow-by. Blow-by. No blow-by. Okay? Now, if you've ever driven a car and you notice coming out the tailpipe blue-gray smoke, that is an indication that you are burning oil. So you have to ask yourself, how is oil getting into my combustion chamber and burning? One possibility is that the oil control ring is not doing its job. Maybe it's worn out. And now all of a sudden this oil that's here is getting up here into the combustion chamber. We have to consider that. Okay? There are other ways that the oil can get into the combustion chamber, but that's one of them. Okay? All right, here we go. First question for today. I'm gonna talk through this a little bit before you answer it, so just hold your horses for right now. So here's the question. An engine comes into the shop with blow-by. Tech A says the engine could have a cracked flywheel. Tech B says the rings could be worn. Who is right? Okay? So again, we have to understand that an engine comes in with blow-by. We have to know what blow-by is. Okay? Now, we have two techs. We have Tech A, we got Tech B. You have to individually evaluate what Tech A is saying. And you have to ask yourself, what Tech A says, is that true or is it false? Then you're going to have to take a look at Tech B and ask yourself, is what they said true or false? If Tech A statement is true, then A is your correct answer. If Tech B's statement is true, B is the correct answer. If both Tech A and B statement is true, C is correct. If both Tech A and Tech B statements are false, then D is correct. Okay? Do not let what Tech A says influence what Tech B is saying. They're two completely separate statements. All right? That's kind of critical because sometimes these questions get a little tricky in regards to not necessarily giving you confidence in what you're doing. Okay? Hopefully that helped kind of explain what I'm looking for out of this question. That's the wrong one. Yep, that's the right one. Boom. Okay. What do you guys got for answer? Make sure your fingers are not in the way. There we go. Remember, this stuff's graded, so please make sure that you're holding your card up so I can scan you. There we go. Good? Did we get everybody? I think I got you. Yeah. Okay. All right. Based off of my statistics here, 69% of you answer that correct. So I'm going to call on somebody who got the right answer, and then you can tell me what you put down. So let's say Dakota. What do you put down? Tech B. That is the correct answer. Okay. So Tech A statement is false. What makes Tech A statement false? Okay, let's kind of break this down a little bit. Okay, engine comes in the shop with blow-by. What is blow-by? Look at your notes. We talked about it. What's blow-by? Opposite of that. Instead of oil trying to get into the combustion chamber, what's trying to get out of the combustion chamber? Air fuel mixture, okay? When gases are escaping past the piston and up against the piston in the cylinder wall, that's called blow-by, okay? So that's the definition. Now, Tech A says the engine could have a cracked flywheel. What's the flywheel? Where's that located at? That's located on the crankshaft on the outside of the engine. Does the flywheel impact air-fuel gases from escaping the combustion chamber? Nope. Okay, so that's what makes it false. What does prevent blow-by? The two rings on the piston, the two top rings on the piston. So that's why Tech B is correct. Boom. Okay, hopefully that made sense. Let's go ahead and move on. Okay, so we're going to kind of put the engine block aside for a second, and now we're going to talk mostly about the cylinder head and its components. Okay, so you guys probably saw this at the beginning of the hour. Let me go ahead and draw this again. Here's my engine block, like literally, right? I got my cylinder that goes in here. I got my piston that's inside the cylinder. Okay, I got my connecting rod. That connecting rod comes down here, is hooked up to our crankshaft. Crankshaft is attached there. I know, it's such a beautiful drawing, right? Okay, I could even come in here and say, okay, we got 3 control rings, so on and so forth. Engine block. The cylinder head sits on top of the engine block. All right, now in between the cylinder head and the engine block is the head gasket. I'm not going to necessarily draw that on here because we're going to try to talk about this. Okay. Now, the cylinder head contains the intake and exhaust valves. It also contains the ports, which are going to allow air to flow in and the exhaust to flow out. Okay, so again, if I come in here and I'm going to draw this, here's the cylinder head, there's the combustion chamber. I'm going to have a port where the air is going to come into the combustion chamber, and I'm going to have a port for the exhaust gases to come out. Okay, so intake port, exhaust port. I'm also then going to have a valve right here that's going to open up and allow the air to come in, and I'm also going to have a valve that's going to open up and allow the gases to come out. Okay? So we've talked about 4 different components. Intake port, intake valve, exhaust port. Now, there's going to be more things that we're going to add to that, but that's where we're going to start. Okay? Now, let's focus in on the valves here for a second. The valves, again, I'm going to kind of draw this over here for a second. Here's a picture of a valve. You ever play the game Sorry? Yeah, it's kind of like a sorry piece, okay? The valve is going to slide up and down. It's going to open and close through something called a valve guide. Okay, that valve guide is like hinges on a door. Okay, because this door opens and closes. And what allows it to open and close are the hinges. Follow me so far? Okay, the valve opens and closes, and the guide acts like a hinge. It allows it to kind of slide and guides it to be able to open and close. Okay, so on this particular example here, this blue part is my valve. This yellow part right here is my guide. All right. Now, I'm going to show you a picture later on in the presentation, which kind of gives you a better image of what this looks like. Okay. There's a bunch of stuff up here that we haven't talked about yet, which we will. Okay. But that's the valve guide. Now, because the valve is opening and closing, right, it's going to be needing to seal to prevent the air and fuel mixture from escaping. Okay? Just like I have my door jamb, which is this right here. The door fits into that door jamb to seal it shut. Okay? On a valve, we have a valve face, and we have a valve seat, which is kind of machined into the cylinder head, for lack of a better term. Okay? Those match each other. They made up with one another. They're basically the same thing, so when it fits together, it seals it shut. All right, so again, if I have my valve here, there's a spot right down here that's going to be the valve face. And then there's a corresponding piece that matches that. And that's the valve seat. How many of you have ever sat in a very, very, very comfortable chair? You like sit in and you're just like, oh, this was made for me, right? Because it conforms around you and it's super comfy. Okay, that's kind of the concept. This valve, the face, is going to sit on the seat, and it's been made for it so it conforms around it. It's very comfortable. Unlike these black chairs in this room right now, where you're sitting and you're like, oh, this is so uncomfortable. Because it's not made for you, it's just made generically. Same concept. And the whole goal is to seal that combustion chamber. Okay, so that's talking about the valves. We'll come back to the valves here in a little bit, but one other thing I need to talk to you about ahead of time is, how do these valves open and close? What's the mechanism that forces it open or causes it to shut? Well, the item that's going to cause it to open is called the camshaft. Okay? Very, very critical part of our engine. Okay, and again, its responsibility is to operate the valves, open the valves up. There's two different locations that we can have our camshaft, depending on the design of the engine. We could have a push rod engine where the camshaft is located inside the engine block. Or we could have an overhead camshaft engine where the cam is located in the cylinder head. Okay? Now, I'm just going to talk through this. You don't have to necessarily write this down. It's just more important that you know that a push rod engine, the cam is located in the engine block, overhead camshaft is located in the cylinder head. Okay? So let me talk you through this. Right here's the cam. Boom. In this example. Okay, this is going to be turning. As that turns, it's going to push on this push rod. It's going to go up. Okay, that's going to push up on this. This part right here is called a rocker arm. Again, you don't need to know this. I'm just showing you kind of how this works. This rocker arm is going to rock back and forth, kind of like a seesaw. You guys know what a seesaw is? Okay, little seesaw right here. When this pushes up, it pushes down on the valve, and the valve then opens up. That's how that works. The camshaft in this push rod engine in the engine block. Okay, let me erase this real quick. Okay. If this camshaft right down here is located up here, as this turns, it's going to essentially push on that valve without the need for a push rod or really a rocker arm in that matter. Okay? The camshaft now is overhead, right? It's overhead, it's up here because it's located in the cylinder head. Is there anything I can clarify about this that you might have questions on? That was kind of a lot to kind of take in. No? All right. Let's ask you a different question here. The distance a piston travels up or down in a cylinder is limited by the, and you have these four options. You have flywheel, camshaft, crankshaft, valve train. I'm going to be very upfront with you right now. I did not specifically tell you this information when we were going through it. Okay? Because again, I need you to understand that sometimes the information I'm sharing with you, right, you have to infer information to the different parts to kind of understand exactly how to answer the question. If you ever come across a test question like this one, where you don't necessarily know the answer 100%, my advice to you would be to try to eliminate as much stuff that you know is not going to limit the piston travel up or down in a cylinder. Okay? Start thinking about what a flywheel is, what a camshaft is, what a crankshaft is, what a valve train is. Try to start eliminating that to give you your best option to select one. Because guess what? One of these options is going to limit the piston travel up or down in a cylinder. Okay, here we go. Let's see how we do. teammates. You got his card.
Me?
Yeah. So where's your card at then? Is that on your notebook?
No, that's the one that was here.
Someone's messing around. Maybe they got two cards next to you. Is one of them was it 8? Yeah. Okay.
Thank you.
There we go. I have no idea why that card's there. Okay, hey, there we go. Now we got it right. Alright. 60% of you got that one correct. Not too shabby. Let's see here. Shayla, what'd you get? What's your answer? C. That is correct. Nice job. Nice job. If I ever call on you, just know that you have the right answer. I'm not going to call on you if you got the wrong answer. So anyways, C, the crankshaft is going to limit the piston travel up or down in a cylinder. Okay, it's limited, or it's limiting that. So let's, again, go through this. The flywheel, what's the flywheel? It's on the outside of the engine, on the flange of the crankshaft, right? It's not really interacting with the piston. So I could probably safely eliminate that. How about the valve train? The valve train, is that interacting with the piston? Is it causing the piston to go limit up and down travel? Nope, probably not. Okay, so there we go. I can eliminate those two options. Now it comes down to the camshaft and the crankshaft. We just got done talking about the camshaft. What's the job of the camshaft?
Operating the valves.
Operating the valves, opening and closing the valves. Boom. Well, gee, I only have one option left. Guess what the right answer is? It's the one that remains. So there you go. C is the correct answer. All right, again, I'm going to try to draw this a little bit more because this picture doesn't really do it justice. The camshaft lobes, or I should say more specifically just the camshaft in general, is not going to directly come in contact with the valve. Okay, again, the camshaft is responsible for opening the valves, but the camshaft does not directly touch the valve. All right, so again, if I come up here and I got an overhead cam, I got a circle, and then what happens, I kind of got this little lobe that pops out like this. Okay, that lobe is what's going to end up pushing and opening this. That's what's called a cam to begin with. So as this is circulating around and rotating, when this valve right here, this is what's going to push down on that valve. Okay, but in between the valve and the camshaft, I've got a piece of equipment here called a valve lifter, or it could be called a valve tappet or a cam follower, depending on how the engine or cylinder head is set up. That's going to be in between the two, and this is it's going to help reduce wear and tear on not only the camshaft but also the valve. Okay? That's kind of the big thing there. Alright, all it's doing is trying to reduce wear. Because again, that cam is hitting that valve, right, thousands of times a minute. If we didn't have that lifter, tappet, or follower, what would end up happening is that valve stem actually would start to mushroom out because it's getting hammered all the time, okay? Which can eventually end up causing that valve to not function correctly. All right, here's that picture I promised you earlier to be able to see the valve and the guides. So again, just want to reiterate, here's the valve right there. Kind of looks like my drawing. This blue section, that's the guide. So this valve is moving up and down, and that guide is guiding it so that way it's not wobbling back and forth and moving around, okay? Now, a valve seal is going to be put on top of that guide, and all it's going to do is prevent oil from leaking in between the valve guide and the valve. You know how I told you about the oil control rings on the piston, and that's helped prevent oil from getting into the combustion chamber? This is another way that oil could potentially get into the combustion chamber, is if this seal right there is not working properly. What ends up happening is the oil that's up in the cylinder head gets in between the guide and the valve. It leaks down here, and then when this valve opens up, that oil drips into the combustion chamber. So we don't want that. So we basically put a little hat that looks like this on that, so the valve can still move it up and down, but it seals it. We know that the camshaft opens the valve. Well, then what closes it? That's our valve spring. Valve spring. Come on, valve. There we go. Valve spring. So as soon as the camshaft is moving away or lifting off of that valve, the spring is creating tension to shut that valve as quickly as possible. This spring right here, it takes hundreds of pounds to be able to compress it. Like literally, hundreds of pounds to be able to compress this. If I gave you one of these springs, and I'm like, hey, you need to compress this, you wouldn't be able to do it with your bare hands. Okay, I doubt you would even be able to do it if you just stood on top of it. Okay, these things are extraordinarily strong. Okay, and they need to be. Because again, the timing of that valve opening and closing is critical. If we don't close that intake valve when we're trying to compress that, all that air fuel mixture that just went in is going to leak out. Or vice versa, right? The exhaust gases. That exhaust valve doesn't close right when it needs to, right? The air fuel mixture is going to go right out, which can be a problem on a lot of engines. Okay? How are we doing? What time are we at here? 38?
35.
Holy goodness. All right. Last question for today. Tech A says the engine camshaft converts reciprocating motion of the piston into rotary motion for power output. Tech B disagrees and says the crankshaft performs this function. Who is right? Just because Tech B disagrees with Tech A does not necessarily mean that they are true or false. Evaluate each statement independent of one another. That's critical. Let me do this here. How are we doing? How are we doing? Gotta get everyone to get answered here. Alright, we good? I think so. Okay, this is one you guys struggle with a little bit. 29%. Liam got it right. What's the correct answer, Liam? B. B. Tech B is correct. Hold up, don't stand up yet. Let's process this for a second. Why is Tech B right and Tech A is wrong? What's the difference between Tech A and Tech B? Tech A is saying the camshaft performs this function. Tech B says the crankshaft performs this function. What's the camshaft function? Open and close valves. What's the crankshaft function? Right? It's going to spin. It's going to basically convert the reciprocating motion, up and down motion of the piston, into circular motion. There we go. Utilizing every single second of class. Super exciting.
It's like one question ahead of the other class.
Yeah, we're like we're similar. All right.
Have a good afternoon.
You as well.
Thank you. He said he's going to go talk to somebody or try to talk to somebody today. So I was like, well, let me know because I really don't want to have to walk all the way down there if I don't have to.
Right?
Today is my favorite day of the week this week.
Yeah.